a function satisfying the following. F prime is equal to x square root of f of x for all real numbers x, given f of 3 equals 25, find f double prime of 3. So you have to do your product rule. So the second derivative would be equal to the first times the root of the second plus the second times the root of the first. After you do your product rule, then you just start plugging in the numbers for x. So at this point, all I'm going to do is start typing in f double prime of 3 equals 3 over 2 square roots of f of 3 times f prime of 3, which is x square roots of f of x. So you have to substitute that in. So that would give me 3 square roots of f of 3 plus square root f of 3 times 1. Root f of 3 over f of 3 cancel. 3 times 3 is 9 over 2. Square root of 25 is 5. So you get 5 plus 9 over 2, which is like 45. Or 19 over 2. Good. So unit 7 is on differential equations. Again, when we first talked about it, that sounded like, what? So a differential equation is simply when you are given a derivative of a function and that derivative includes multiple variables. So x and y, a and b, etc. Solving a differential typically means we start with a derivative and we work backwards to find the original. We are usually given an initial condition that helps you find your constant. So again, these are the ones where you're seeing our plus c's come into play. Sometimes finding their solutions can be challenging. They often involve e's and ln's. We often have separable differential equations, and we have to do what we call find the general, which has that plus c. So you have dy dx equals f of x times g of y. You need to get the y's with the y's and the x's with the x's. So this is where we would divide by gy and multiply by dx, because you must match your variables to their constants of integration. You cannot take an integral if the constant of integration is not with its value. So you must have a dy or a dx every time you have an integral. That is also why on AP, if you write the integral in and you don't put dy, you lose a point. So on your tests, if you didn't give me dy or dx, I took away a point. This is also where we brought in our exponential functions. So this is where we had our dy dx equals ky. We often saw it in this case right here. Remember that y naught is a fancy way of saying initial. We often see this in our problems. It often becomes the C value. You have growth if k is positive. You have decay if k is negative. Going back to our original warm-up, it said let f be the function satisfying the following. We are given the following. Now we want to work backwards. I want you to take your derivative and find f. So we're going to change f prime to dy dx. We're going to change f of x to y. So it's important to note that this is equivalent to that. The two boxed in values are equivalent statements. They mean the same. So what we want to do is get the x and dx together, the y and dy together. Thus creating 1 over the square root of y equals x dx. We're going to integrate both sides. So this is like integrating y to the negative 1/2. So remember, our rule is that you add 1 and divide by your new exponent. So we get y to the 1/2 divided by 1/2, which is really the same as saying y to the 1/2 times 2. This is x to the 1. That becomes 2 over 2. And we cannot forget our constant c. We're integrating without bounds, therefore c. We were given initially that x is equal to 3 and y is equal to 25. So we're going to take that x equals 3 and that y equals 25, and we're going to use them to find c. So you have the square root of 25, which is 5. 2 times 5 is 10. 3 squared is 9. So then you have 9 halves, which is 4.5. So again, 10 minus 4.5, giving you 5.5. It asks you to write an expression for f of x, or y equals. So at this point in time, we have not solved or gotten to that point. I found my c value, yes, but I did not write my expression or solve for y. Right now I have 2y to the 1/2. I need to solve for y to get my final answer. So I need to take that c value and plug it back in. And since I have fractions and 2's here, I'm going to change that 5.5 to 11 halves. And you'll see why in a second. So by doing that, it's going to create a common denominator, and that common denominator is going to eventually end up being a 4. So I get x squared plus 11 all over 4. I still don't have y solved for, it's the square root. How do you get rid of the square root? We square it. That is my f of x. Okay, let's look at a second or another example. So we have dy dx equals x over y squared. Again, the only way to solve this is to get y's on the left, dx on the right. So I end up with y squared dy equals x dx. Now I'm going to integrate both sides. So go ahead and find your antiderivatives. Don't forget your plus c. So you get 1/3 y cubed equals 1/2 x squared plus c. Solve for y. So you have to multiply everything by c, or by 3. Remember that c is a constant, so you don't write 3c in your answer. The c absorbs the 3. And then take the cube root. The c is inside that cube root though. The c would be inside my cube root. With Unit 7, we also discussed differentials and slope fields. They went hand in hand in the sense that a slope field is a visual representation of a differential. Hence the word slope field. Remember that slope and derivative and rate of change all mean the same thing. So when you have a slope field, you have a field of derivatives. It allows us to find the equation or see and understand a graph. So one of the slope fields is the differential dy dx equals sine x plus y. And the other is the differential equation of dy dx equals sine x minus y. How could we figure out where or why which is which? So what I would do is ask myself some of the simple questions. If I make x 0, 0, what I notice on my graph is that these 2 points are different. So if I explore here versus there, so same xy ordered pair, but one is positive and one is negative, then what I could do is plug in that ordered pair to both. So you get 0 plus 1, which is 1. So the sine of 1 is going to put you in quadrant 1. So you know that the sign of 1 in quadrant 1 would be positive. We don't know the sign of 1. The sign of 1 is not a unit circle value. It is not something you should know. However, in terms of the unit circle, you should know that this is 0, this is that 1.57, this is 3.14, and then this is roughly 3.5. So if you 3 halves 5, which is 1.5, times 3.14, so then it's going to be 4. To give you an idea of what quadrant you are in. So here, if you get the sign of -1, well now that means you went +1 this way, -1 that way. All students take Calc, sign in quadrant 4, therefore this is negative, so x plus y is positive, this slope is positive, therefore x plus y is a, slope is negative, this is negative, therefore x minus y is b. Their other suggestion is looking at where the slope field had a slope of 1. So if you had picked a y, an x and a y that was at that point, which I think is more difficult than picking kind of where we picked, because there's no like units on the slope field. But if there were units and you could find where it was horizontal, then you could also go and kind of work backwards and say, okay, when would this equal 1? And you would say to yourself, okay, when is the sine 1? The sine is 1 when x plus y. So you would get your unit circle. That's what I think that was fun. I like just picking 2 points, same spot, comparing their slopes to see which is which. And then last, consider the differential equation. dy dx equals x to the 4th y. This was off an old AP exam. They actually had you provide the slope field. It says provide a sketch of the slope field given the following differential using all 12 points. So the easiest is to consider x equals 0, because when x equals 0, everything is 0. A -1 and +1 for x, they're also going to be the same. So you're only comparing your y's. target is only drawn at 12 points. It is defined at every point in the xy plane. Describe all points in the xy plane for which the points or the slopes would be negative. So when or why would all of the slopes be negative? So what you would do is you would talk about the fact that y equals 2 is a horizontal asymptote. So because x of 4 will always be positive, the slopes will be negative below the horizontal asymptote y equals 2 because y minus 2 will be less than 0. Or you would say when y